In example 7 here, we're given a square with an inscribed circle, and that circle is called M. So we need to find the diameter and the radius. Now, whenever we have the square being circumscribed around the circle, we can see that the distance all the way across is going to be 18 feet. So if we're looking for the diameter, it's going to be 18, and it's good to keep our units on there. The radius is always half of the diameter, so our radius is just going to be 9 feet. And our circumference, we know circumference is equal to pi times diameter. So if we take our diameter of 18 feet and multiply that by pi, we would say 18 pi, and we can still call it units of feet, because circumference is a distance. It's the distance around the outside of the circle. So 18 pi feet. If you want to draw a little divider here so you can clearly see which problem is which, we can do that. We're given circle Y, so it's talking about this picture down to our right, and we need to find angle AYC. So angle AYC. One thing we know about any angle that goes all the way around in this way is that we have a total of 360 degrees to work with. Now if we subtract away the 90 and we subtract away the 110, together those are 200, that leaves us with only 160 degrees remaining. So the measure of AYC is 160 degrees. Now we're asked to classify each arc as major, minor, or a semicircle and to give the measure. So we're going to start with AB. So AB goes from here to here, and we have 110 degrees. So that would be a minor arc because it's only 110. So minor, 110 degrees. AC is going to go this direction here. It's going to go A to C. Again, not more than a half a circle, so it's again minor. It would be 160 degrees. Next we have angle, or arc ABC. So we go to A to B and then keep going all the way to C. That arc, as you can see, is longer than 180, more than a half circle. And if you add up the 90 and 110, as we did earlier, we get 200 degrees. So that is a major arc, and that is 200 degrees total. And then the next one, ACB. Notice how it's the same letters as ABC, but a little bit different because it says go to A, then go through C, and then continue on all the way to B. So that is a different arc than what we drew earlier. We add up our two components. We have 160 degrees and 90 degrees, and together that forms 250. So that is a major angle, because it is more than a half circle. 250 degrees. Draw a little line again here. Number 9 says find the arc length of CD. So the arc length around the outside of a circle is always a portion of the total circumference, a portion of the total distance around the circle. And although it's not clear here, this is 30 degrees, so you might have a little degree sign on there. It's poorly written. We have a radius of 6, so our radius is equal to 6. If our radius is 6, our diameter is 12, and our circumference, which is pi times diameter, is going to be 12 pi. So that is our circumference. Now we want to figure out the arc length. So take our 12 pi, which is the total distance around. So that 12 pi refers to that total distance around. Both of those are highlighted there. What we're going to do is for our arc length, we're going to say the arc is equal to our circumference, 12 pi, times whatever fraction of the circle we actually have. So we only have 30 degrees of the 360. And if we were to reduce these fractions, we would say, okay, the 10's cancel, leaving us 3 over 36, which reduces to 1 over 12. So we have 1/12 of 12 pi remaining. Well, what's 1/12 of 12? That 12 and that 12 will cancel each other out, leaving us with just pi. So 1 pi, or just pi, is the arc length of this right here. So we could label that as pi. Continuing on, we need to find x in this diagram. We know that all the way around it's going to be 360 degrees that we're working with. So we're going to add up to 360. That plan works great until we realize that we are actually missing this angle right here. So how are we going to deal with that angle? Best way to go about it is to notice that we have a line continuing across and another line continuing across, which means that we have vertical angles, and these two are the same. So the fact that this is 5x plus 5 down here means this is also 5x plus 5 in that angle. And now you can add up all the way around the circle and set it equal to 360. So let's do that. So we have, start here with the 20x. 20x plus 5x plus 5, and I'm going around counterclockwise, plus 13x minus 3. So I got this one, this one, this one, plus 8x minus 4, plus 5x plus 5, and that's all equal to 360, because it's a complete all the way around the circle, all around the central angle. And let's combine our like terms here. We got some x's, quite a few in fact. 25, 28, 38, plus 8 more would be 46, plus 5 more would be 51. So do that in your head, do that in the calculator, we get 51x. And then our remaining terms, we have a 5, a negative 3, so that's 2. Minus 4 would be negative 2, plus 5 would be positive 3. Still all equal to 360. Subtract 3 from both sides and we get 357 is equal to 51x. And when you divide both sides by 51, do that in your head, do that in your calculator, and it's going to be x is equal to 7. As normal, you can always plug that back in. So we get 140, 7 times 20. 35 plus 5 would be 40. We get that up here as well. 40 degrees. 7 times 8, 56, minus 4 is 52. 7 times 13, 70 plus 21 is 91. Minus 3 is 88. So you put that all together here. And if you want to make sure it still equals 360, right here we have 140. Get this to 180, which makes sense that we have a straight line here, and this part alone is 180. And this side here, 40 and 140 is 180, and together that's 360. So that's another approach you could have taken, is splitting it into two half circles and done 180 apiece, but either way, this is going to get us the right answer.